Hello, my name is Valerie Stolp, and I will be reporting my results and observations for Physics 2212 Lab 2, Charge Tape as a Line Charge. The purpose of this lab is to estimate the amount of charge on a piece of tape using observations from Lab 1. In this lab, a more accurate model will be used to calculate Q. This lab treats the tapes as a line of point charges with even distribution. To use this model, I assumed that the width of tape was negligible to assume only one atom in the width, as well as assuming equal charges between the top and bottom tapes. My results show that the charge of a piece of tape is equal to the magnitude of the gravitational force acting on the top tape, but of a larger value than that found from the point charge model in Lab 1. Interactions between the charged tapes and other objects reveal that the pieces of tape are positively charged. The physics principles used to come to the conclusions were Newton's second and third laws, Coulomb's law, and superposition. The application of these principles will be explained later in this video. In order to determine the sign of the charged tapes, I observed and documented the interactions between the tape in my hand, a wooden table, a negatively charged plastic pen, and another charged tape. The U-tape showed a moderate attraction to my hand and the table because these objects should be neutral and show some attraction. The plastic pen and the U-tape showed a strong attraction. Because we know that the plastic pen has a negative charge, it was then found that the U-tape must have a positive charge. Because two identically prepared U-tapes repel each other, it was clear that they were both positively charged. To determine the actual magnitude of the charged tapes, Newton's second and third laws were used to equate the gravitational and electric forces so that the charge could be solved for. In order to do this, it was necessary to assume that the two charged tapes would have charges of equal magnitude. In the two-tape system, all momentum is conserved because the two equal and opposite forces are acting on the floating tape. To solve for the tape charge Q, the electric force was set equal to the magnitude of the known gravitational force, and then used to solve for Q. Given that the tape length was 0.254 meters with a mass of 2.54 times 10 to the negative 4th kilograms and floated at a distance of 0.048 meters above the tape below, it was calculated that the value of Q is 2.53 times 10 to the negative 9th coulombs. This value was used as the estimate for Q in the glow script model. To build the computational model, the parameters and constants from the previous slide were entered into the code. However, my original estimate for Q from the point charge model gave a much smaller electric field value than what was expected, so through trial and error, I found that 4.7 times 10 to the negative 8 coulombs was a better estimate for the charge of a piece of tape. In the image to the right, I defined the calculations for the electric field by inserting lines of code to calculate the distance vector, its magnitude, and its unit vector, to be used in Coulomb's law in line 29 as observed at a certain location. Lines 35 to 46 were written from the starter code to build the visual model. Lines 64 and 65 were updated to account for the tape length, 0.254 meters in the x direction. The variable top tape has a starting position at y location 0.048 meters to represent the floating distance. The tape was broken into 10 segments to model as a line charge. The e-scale was chosen to be 1.5 times 10 to the negative 6 in order for the individual point charges on the line to visually sum to be equal to the overall tape charge. Lines 85 to 100 loop through all 10 segments of the tape to calculate the electric field at each individual point charge in the tape. Finally, in the rightmost image, the arrows were created for the overall electric field value on the top tape and the gravitational force. This glow script visual is depicted here to show that for a tape consisting of 10 segments, each individual segment has its own electric field value that has both x and y components. This is because gravity acts on the mass center of the tape, so point charges near the ends of the tape will have a larger x component value. Using superposition, all of these tape point charge magnitudes are summed to give the overall electric field of the tape, the white arrow, which equals that of the yellow gravity arrow. In this model, with 10 charges in a line, the electric force is equal to 2.49 times 10 to the negative 3 in the positive y direction, and gravity equal to 2.49 times 10 to the negative 3 in the negative y direction. To summarize all of these results, I found that the U-tapes were positively charged after observing the interaction between a tape and a negatively charged plastic pen. Using Newton's second and third laws, I was able to assume no other forces other than gravity and the electric force were acting on the top tape in order to find the approximate magnitude of its electric field. These results, however, are not completely accurate. Deviations may have occurred from error in measuring the floating distance between the two tapes, as well as the fact that the tapes did have a significant width, so the tape could be more accurately represented as a series of parallel line charges. Also, slight differences in amount of skin contact of the two tapes would affect the magnitude of the charge. Overall, I found that the magnitude of the electric field is 2.49 times 10 to the negative 3 coulombs, equal to that of gravity, but with a charge of 4.7 times 10 to the negative 8 coulombs. If a single point charge model had been used to calculate the charge magnitude, 2.53 times 10 to the negative 8, the original estimate would have been the value of Q. However, using the series of point charges instead of just one single point charge, the charge was found to be 4.7 times 10 to the negative 8 coulombs, about twice as large as the estimate from the previous lab. These charge values differ because the point charge model from Lab 1 does not account for any electric force in the x direction, even though it was seen from this model that there is some x direction contribution. This occurs because gravity acts on the mass center of a body, so charges that are not aligned with the gravitational force need to be considered. The line charge model accounts for these point charges with an x component contribution, so the value of 4.7 times 10 to the negative 8 coulombs is a more accurate value for the tape charge. Thank you for watching.